First, we need to remove the outer cover before we can remove the screws. To do this, we need to heat the outer cover with a hot air gun with temperature set to around 250 degrees centigrade. This is done in order to soften the butyl glue. Gently push with the screwdriver to pry open the outer cover. Once the outer cover is removed, we have now the access to remove the 4 screws, which hold the transparent headlamp front cover to the black headlamp base cover. Once the 4 screws are removed, we need to further remove the butyl glue, which is completely sealing the headlamp to make it waterproof. Now, once the reflectors are accessible, remove the screws at the top, holding the headlamp reflectors. The top and bottom reflectors are also connected to each other by screws, which has to be removed to open the reflectors. This is not shown in the video. Once the reflectors are removed, you can see the driver board behind, which is also secured by screws and connected to both reflectors through clip-on connectors, which needs to be removed. We are replacing the stock 3 watts high beam with a spot beam projector, which has a low beam yellow light of 18 watts, high beam light of 8 watts, and a projected rectangular wide spot beam of 12 watts. The projected beam has non-scattered light due to the projection lens arrangement. This projector is originally meant for fitting outside as auxiliary lamps. But since we are repurposing this to fit inside the headlamp, we need to make a few alterations on the projector body. We need to remove the mounting projections by cutting them off with a saw blade. Now let's test the existing headlamp to check how the low and high beam works. First, we are powering the low beam light. We observe 2 LEDs glow, which are connected in series to consume a total 7 watts. When we power the high beam light, we observe that the low beam and high beam lights glow together, consuming a total of 10.5 watts. If we remove the high beam LED from the driver board, we observe that the low beam light then do not turn on in high beam mode. In order to keep the low beam turned on when high beam is turned on, we need to connect a diode from high beam line to low beam line. This will allow high beam and low beam to be turned on when high beam is turned on and prevent high beam from turning on when low beam is turned on. The projector has 3 wire connections. A black wire, which is the ground or battery negative. A red wire, which is used for spot beam activation when connected to 12 volts or battery positive, and yellow wire for toggling high beam, white and yellow beam low modes, when connected to 12 volts or battery positive. The diagram shows the complete wiring to be made. We have 2 additional switches provided. One switch is for turning on the spot long-distance projector beam. The other switch is for turning on and toggling low beam yellow and high beam white light of the projector. This integrates with the existing low, high, and flash switches of the bike. Now we are making the connections according to the circuit diagram. The wires can be tapped either from inside the headlamp or outside from the headlamp connector. All wires are soldered and heat shrink sleeves are applied to ensure proper connection and insulation. Now you may think why we need so many connections in this circuit. Firstly, you get flexibility to turn on only the existing bike low beam without turning on the new projector lights. Secondly, with the existing bike switches of flash and high beam, you can turn on the projector spot beam. The cluster indication on the headlamp will show the projector spot beam turning on as high beam. The spot beam can be turned on by an independent additional switch. Thirdly, all the lights, that is the existing bike low beam, new spot projector beam, and new yellow low beam or white high beam can be turned on, giving you a total light output of 37 watts, which is much more than the existing light output of just 10.5 watts. This projector dimension precisely matches the available space inside the headlamp. You can observe the projections inside the headlamp, fitting to the corner of the projector. We can firmly fix then to the sides by using any epoxy glue like JB Weld. The top side of the projector is fixed to the low beam LED reflector with a double-sided tape so that it can be removed when needed. The double-sided tape used here is 3M VHB tape. Now that we have secured the projector inside the headlamp, we can now close the top transparent cover. We need to ensure that it is fixed firmly without any gaps, as it was in the original fitting. Once the top cover is closed, we can fix the 4 screws and tighten them. We can check the gaps by putting on the outer cover and check for proper seating. If the seating is fine, then we can remove the outer cover and seal all the gaps with the heated butyl glue. The waterproofing is achieved by the glue which was removed when we opened the lamp. In case you don't have butyl glue tape, you can also reuse the glue you removed while opening the lamp. To reactivate the glue, all we need to do is to heat it with a hot air gun. Here, I have used the screwdriver to apply the glue evenly around the gaps. The diode is connected between the low and high beam wires. It's placed outside on the wiring and sealed with a heat shrink sleeve. We have 3 additional wires coming outside for the 2 handlebar switches. 1 wire is common for both the switches, and 1 wire, if connected, will turn on the spot beam, and other, if connected, will toggle the white high beam and low yellow beam of the projector. Here we are connecting first the 2 new handlebar switches. You may be thinking this is too complex to do on your own. So if you find installing projector inside headlamp difficult, then you can install them easily on both sides as external fog lights. All things which you need in this project, which are mentioned in this video, are available on Amazon. This includes the handlebar switches, wiring kit for aux lamps, and mounting side clamps for aux lamps.